tonight we're going to be looking at solving word problems with equivalent fractions, or trying to find equivalent fractions within word problems. Alright, so here's our current problem. Anaya is planting a flower garden. The garden will have no more than 12 equal sections. 3/4 of the garden will have daisies. What other fractions could represent the part of the garden that will have daisies? So we want to find out what other fractions could represent the part of the garden that has daisies. Okay, super important. Alright, so Anaya is planting a flower garden. The garden will have no more than 12, so it could have 12 or less. And 3/4 of the garden will have daisies. Okay, so we have 3/4 are daisies. Oops, I don't want to use that and confuse you. 3/4 are daisies. No more, so our denominator is going to be no more than 12. Okay, so denominator. Okay, and that's all the information we know. Let me split screen this. Alright, so what do I want to do? Alright, so here we have our information. Now we need to figure out what that number is. What other fractions can we have that has a denominator no more than 12? Okay, so the book shows you how to draw pictures, but I found it a little bit confusing. So I'm just going to go ahead and use what we just learned yesterday, and that was, or last night, and that was common multiples. Okay, so I know I have 3/4. So I'm going to circle my denominator, and I'm going to do the multiples. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Okay, and I don't need to go 4 times 4, right, because it's 16, and that's higher than 12, and this tells me no more than 12. Okay, so I'm going to do the same thing to the top. So if I'm going to have this, these are going to be my fractions. So 3 times 2 will be 6. I'm sorry. 3 times 1 is 3. 2 is 6. 3 is 9. Okay, so these are actually my fractions that will be replaced. So 3/4 is the same, 6/8, and 9/12. Those are the fractions that are equivalent, right? Because 4 times 1 is 4, and then what I do to the bottom, I have to do to the top. So 3 times 1 is 3. If I go to 8, 4 times 2 is 8. Whatever I do to the bottom, I have to do to the top. So it would be 3 times 2 is 6, and so on and so forth. Okay, so my answer then would be 6/8 and 9/12. Okay, let's take a look at another one. All right, we have some friends that are making scarves. Okay, each scarf is 3 rectangles, and 2/3 of the rectangles have stripes. So 3 doesn't even matter at this point. 2/3 is our fraction. If the friends are making 10 scarves, how many rectangles will they need, and how many rectangles have stripes? So there's 2 questions. How many rectangles? How many stripes? So this would be my denominator. This is going to be a numerator, or fraction, part of the fraction. All right. Let's see here. So we have the number of scarves here. So on this top row, we're going to have the number of scarves. So 1, 2, 3, 4, 5, 6, all the way up until 10, because that's how many scarves we made. And then we're going to have the number of rectangles over the number, a number of striped. Sorry. So this is my number of stripes. This is my total rectangles. Okay, so if I have one scarf we already know from the problem has 2/3 of the rectangles. Okay, and what I can do with this is, since I'm going up sequentially by ones, I can just multiply the bottom number. So I'm going to take my 2 and my 1/3, and let's go ahead and do our multiples. So it's 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30, right? All the way up to 10. That's where I'm going with that. All right, so these are the denominators of my fractions. And what I do to the bottom, I got to do to the top. So 3 times 1 is 3. 2 times 2 is, 2 times 1 is 2. 3 times 2 is 6. 2 times 2 is 4. Okay. 3 times 3 is 9. 2 times 3 is 6. So on and so forth. And you can see the numbers kind of correspond up there as well. So this is going to be 2/3. This is going to be 4 6. 6 9. Okay. 3 times 4 is 12. 2 times 4 is 8. 3 times 5 is 15. 2 times 5 is 10. 3 times 6 is 18. 2 times 6 is 12. 3 times 7 is 21. 2 times 7 is 14. 3 times 8 is 24. 2 times 8 is 16. 3 times 9 is 27. And 2 times 9 is 18. 3 times 10 is 30. 2 times 10 is 20. So our actual answer is this one right here, 20 over 30. Okay, so to answer my question then, how many rectangles will they need? Well, they'll need 30. And 20 will have stripes. Over 30. I know it's kind of confusing to see it in that way, but if you look here, this is what our fraction is. The number of stripes, which is 20, over the number of total rectangles, which is 30. Okay? All right, let's take a look at this math homework, which is a little bit difficult. So I'm going to preload some of it for you, so it's a little bit easier for you to figure out. All right, so Mrs. Grove has trays of paints for students in her art class. Each tray has 5 colors. One of the colors is purple. So that gives me a fraction. 1 out of 5 is purple. What fraction of the colors in 20 trays is purple? All right, so I've got 5 trays here, my total number of trays. Okay, and my other fraction is going to have a total number of trays as well, right? What is that? Okay, well, I have 20 trays. Okay, so if I have 5 trays to start off with, I'm going to multiply them by 20. Okay, and then I'm going to get a fraction here. And what I want you to do is I want you to use this information. So I have 1/5, and I've got to multiply it by 20 to get to a fraction here. Don't forget what I do to the bottom, and that's all I'm going to tell you. So get me this fraction. That's the part of your homework you need to figure out. All right, the next one, Miguel is making an obstacle course. Okay, so we're working on number 3 now. Miguel is making an obstacle course for field day. At the end of every 1/6 of the course, there is a tire. At the end of every 1/3 of the course, there is a cone. And at the end of every 1/2 of the course, there is a hurdle. At which locations of the course will people need to go through more than one obstacle? Okay, so this was a little bit difficult for me. So what I did is me and Mrs. Skata worked together and figured it out. And we had, we drew a course. So let's say this rectangle is our course. And we're going to go through the course. So I'm going to break this rectangle up into whatever my biggest denominator is. So my biggest denominator is, let's see, we have a 1/6, 1/3, and 1/2. Okay, so I'm going to break it up into 6 because that's my biggest number. So let's break these up into 6, 2, 3. Okay, it's not going to be exactly the scale, but it's okay. So this here is 1/6. Okay, and this here is 6/6 or 1/2. Okay. All right, so that would be the end. This is the beginning. This is the end. All right, so it says every 6 of the course there's a tire. So I'm going to draw a tire here. And let's see, there's a tire here, So every 6 of the course is going to be a tire. All right, and let's see here. At the end of every third of a course, there is a cone. So now I got to figure out where a third is. Well, if I have 1, 2, 3, 4, 5, 6, if I divide that by 3, I should have a third here. And another third here. Right? And then 3/3 down here at the end. Okay, so here I have a cone. And then here I have a cone. And then over here I have a cone. Forgot my circle here, tired. Okay, so there's that. And then it says at every half of the course there's a hurdle. So I have 6. 6 divided by 3 is 1. So this should be a half. Okay, and what is that every half? There is a hurdle. So I'm just going to draw like a U shape. Okay, and then there is my 2 halves, which is my whole. Okay, so now I can look at this and see where people would go through more than one obstacle course. Okay, so if you look right here, this is only one obstacle course, right? So this doesn't work. Here's 2, so 1/3 is an answer. Here's 2, the hurdle and the tire at 1/2, sorry. And here's 2 at 2/3. This one doesn't have one, but the end does. So this will be the final, or 1. Okay, so that would be your answer for number 3. Preston works in a bakery where he puts muffins in boxes. He makes the following table to remind himself how many blueberry muffins should go in each box. How many blueberry muffins should Preston put in a box with 36 muffins? So you got to find out the relationship to here. So we have 2, 6, 4, 12. How are we getting from here to here? Okay, and then 24. Okay, how do we get from here to here? Okay, so 6 goes into 12 2 times. 2 times 2 is 4. Okay, you can go with 12 into here. 12 goes in 24. 24 times, or 12 times 2 is 24. 4 times 2 is 8, and so on and so forth. Okay, see if you can figure that out. Your WSQ. Alright, so here is a model. Mrs. Friendly is making rolls for a party. She wants 3/5 of the rolls to be whole wheat. What other fractions can represent the part of the rolls that will be whole wheat? Shade the models to show your work. So in this one, you will have basically 25 pieces. So you're going to need to break this block, this one right here, into 25 pieces and shade the amount. What I would do is I would probably shade these 3 lines and then break them apart into 25 pieces and see how many boxes are shaded up. That'll give you your fraction. And then figure out another one to do. Okay, so I gave you this fraction for number 2, I guess you would say. And number 3, you need to figure out a way to break it apart into another fraction of a multiple of 5. That gives you a hint, a multiple of 5. All right, you guys have a good night.